Experiment 1. So this video is just a little introduction about how to look at the lab report sheet and kind of the order to go in and what to fill out. So the discussion pages are not necessarily needed to turn in. You can only turn in the pages where you are writing. With lab, it's really important to write neatly. If you make a mistake, always draw just a neat line through it and then write your correct number or statement next to it, and to write in pen. So since you're scanning it, I will notice whether you write in pencil. It is really, really crucial to write in pen, and it must be either blue or black. So no other colors, has to be blue or black ink. So before each lab, you will have this little video of me kind of walking you through what it's going to be about in the report sheet, just to get a little familiar with what you are expected to do. Now, lab is a way where we apply what we've learned in chemistry in a physical way. You know, it's like the concepts that we've learned, now trying them on our own to kind of get a little bit of a better understanding. So this first experiment is significant figures. Here, really, the objective is just to get more familiar with what significant figures are, how to look at them, how to know how many to use, especially when we use different devices in measurements. What you'll see later on in any science course is there's going to be a bunch of different ways to measure different things. And it's important to understand exactly how many significant figures you want to write down from every single measurement that you take. So what I would like you to do is, if you haven't already, taking a look at the links that you need to watch to familiarize yourself with accuracy and precision, significant figures, calculating in significant figures, and rounding. These are from chapter 2. If you feel that you're already familiar enough with the material, you don't have to watch it again, but these are the links here. Again, they're also on Canvas. What you'll see every time is you have this objectives, you have this materials that are needed. So then, other than just looking at the links, I would like you to have a ruler if possible. Any kind, it really doesn't matter, just something where you can measure length. So we here study matter, and we know that matter is all around us, and we constantly take measurements in chemistry and lab specifically. Now, that brings us up to the numbers that we record are measured numbers, and we want to record only those digits that are significant. We don't want to write 10 digits. We only care about looking at the important ones. And the way that significant digits work is you write your certain digits, which are all the markings on a measuring device, and then one more digit after that, the estimate, to kind of take into account that there's always a little guess, right? Just like when you take the weight of something, that last digit fluctuates. Eventually it stops if it's a digital scale, because it kind of just took the estimate of that last one. How well a measurement is, it depends on accuracy and precision. So whenever we are in chemistry, you don't just do one trial and say, this is the mass, I'm super confident, that's my answer. We always do more than one trial so that we are more confident that this is our answer. For example, usually there's 3 trials. That's how we're really confident that we can say this is 10 grams, etc. From those trials, you take an average, which is summing up however many numbers you have, dividing it by the number of trials that you did. So if you have 3 different numbers, add them together, divide by 3. How close your average is to the known value tells you how accurate you are. Then, how close each of your values are to each other, so your trials are to one another, that's your precision. So super important when we're in chemistry, making sure we're being accurate and precise, because we obviously want to reach that known value, but we also want to make sure that every trial we're doing, we're being very, very cautious of doing the same exact process every time, so our numbers are very close to one another. Now, there's a few things that take into account with that. One, use the same device. If you're using different devices each trial, you're going to get different numbers. Make sure you're doing the same method. Work slowly, take your time. It's just different little practices to make sure you're being as precise as possible. So this is all already should be review. That's why I'm going a little bit faster, but just to show you when you have a ruler or a graduated cylinder or any type of device that has markings. All of the lines are your markings, right? So those are all certain digits. So up to those lines, you have to write the numbers down. So my little wooden stick here goes up to right about here. So I'm between 4 and 5. So then what do my little markings mean? My big markings are the ones. Ones are just that initial number before a decimal. Then what are my little ones? 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are my tenth spot. So I am in between, this is 0.5 and this is 0.6. I'm between 4.5, 4.6. I'm not at 4.5 or 4.6. Now, because you have the 0.5 and the 0.6, those are your 10th digit, those are your certain, you have to have one more that's your uncertain. So somewhere between that, I'm going to say it is 4.58 centimeters. So you have your certain digits, your uncertain, and your units. We only report significant figures. So a couple rules for significant figures. Any number that's non-zero is significant. A zero that's between two non-zeros is significant. A zero that happens after a decimal is significant because it tells you that there's no estimation of exactly this number. When you're in scientific notation, you're just looking at the coefficient, which is the number before the times 10 to the exponent. Not significant is when there's zeros, even if there's a decimal, but before any non-zero. Also not significant are trailing zeros, zeros that occur after non-zeros where there's no decimal, indicating the significance of the number. Again, going a little bit faster because this is a review. Look at those links where it's slowed down and there's more practice problems. So when you're adding or subtracting, you're going to round your answer to the least number of precision numbers, which is the least amount of numbers after the decimal. When you're multiplying or dividing, you round your number to the least amount of sigfics. So then you're taking into account the entire number. In the instances where you have multiple steps, you follow the order of operations, which is the parentheses. So whatever is in parentheses, you would do first, find the sigfix that. If you have an exponent, that comes next, multiplication, division, addition, and subtraction. So you're going in this order, figuring out the sigfix each time you have a step, and then continuing from there. So then you have a little procedure section. Again, these are the videos to watch to review everything that I kind of talked about more in detail. You then answer your report sheet, your questions below, and you submit to Canvas. So on Canvas, you'll have a little part where it says Experiment 1, Significant Figures, and you upload this file. Again, I don't need the first 2 pages of all the wordings, I just need the part where you filled in. You have to write neatly, you have to write your name on it, you have to write in blue or black ink. Make sure you show all your work. If I don't see your work, you will get deducted points. You're rounding correctly, you're having your units, all that is really important. You can either print this out and scan it, you can take a picture. If you want, and you don't have access to a printer for any reason, or your printer isn't working, you can recopy this on a blank piece of paper nice and neatly, and I'll also accept that as well. So here's your report sheet. You just answer the questions below. So how many significant figures are in the following? Write the numbers from problem 1 in scientific notation. So you answer all of these questions. You perform each mathematical operation and answer the questions that come below it. And then here in part B, I want you to take a ruler and a piece of paper and answer the questions below. Doesn't matter what ruler, doesn't matter what piece of paper. Now these questions will vary from everybody. But what I'd like you to do is you write the unit of whatever ruler you're using and the markings of the ruler. I want you to go through and determine whether the smallest markings are to the 10 spots, 100s, and then kind of go through what we did in the exam